In this lesson, we're going to learn how to use trig ratios to determine angle measures in right triangles. So the first thing you have to know is how to use what we call the inverse trig functions. So basically, if you're given a scenario like this where you have sine A equals 0.6 and you want to know what is that acute angle so that the ratio of the opposite to the hypotenuse comes out to be 0.6. So basically, I want to solve for A. I want to know what's the angle. So in order to do that, what you do is you take what's called sine inverse of both sides. So you would take in your calculator, you might have seen this button yesterday, that with a little -1, that's the inverse. So that's what's going to undo sine. So you're going to take the inverse of both sides. So what happens is the signs cancel, and A is equal to the inverse sine of 0.6. So then to go enter this into our calculator, we're going to go to our home screen, making sure we're in degree mode because we're trying to get out a degree. And then we go down to our trig button, and now notice the little -1s, that's the inverse. So it's going to be sine inverse of 0.6 is what I type in. And you end up with 36.869 degrees. And for this, it doesn't tell us what to round to, so I'm just going to say let's round to the nearest tenth. And I'm going to say the measure of angle A, because A is a capital letter, so remember it represents an angle, is 36.9 degrees. And again, I'm just rounding one decimal place since it doesn't say, I'm just going with that. So that's inverse sine. Same thing applies for cosine. So if you look at the next one, I want to know cosine of what angle will give me a ratio of 3 to 4. So what angle will I take cosine of, or what angle is the adjacent side to the hypotenuse equal to 3 to 4? So that's what it means. So that means I want to undo cosine. I want to get theta by itself. So I'm going to take cos inverse of both sides, and these cancel, and I end up with theta equals cos inverse of 3 over 4. So we go ahead and we type that in. So we have trig. Now we're going down to the inverse cosine. Hit enter, and then 3 divided by 4. And that gives us 41.4 degrees. So 41.4 degrees. And for this one, since theta represents usually the interior of the angle, I'm just going to leave it as theta equals, versus A is a vertex, so I put the angle symbol in front of it. And then for this next one, same concept, it's just we're trying to undo tan, so tan inverse both sides. So those cancel. We are left with x equals into the calculator. Trig, we go down to the inverse tan, and 0.38 is the ratio. What's the angle that will make that ratio true? Is going to be 20.8. And again, rounding to the nearest tenth because the direction didn't specify, so I made up a direction. So then why don't you guys go ahead and pause the video and go ahead and try these 4 problems where you're solving for angle A. And for this, it does say nearest degree. So go ahead and round to the nearest whole number. So go ahead, pause the video, complete those, and then hit play and check your work. So here you have it. I have the 4 different angle measures here. Remember, I rounded to the nearest degree. So all of these except for the 60 came out to be decimals, and then I just rounded them to the nearest whole number. So remember what this is really saying. Tan of 77 degrees is 4.3. Well, I would have to use the exact decimal to get the 4.3. Or sine of 7 degrees is going to come out to be 0.13. So that's what these inverse trig functions are doing. So let's look at, well, how does this actually help us in triangle situations? So if we look at this first triangle picture here, notice my unknown is the angle this time. So I want to find the measure of theta in each triangle, and we're going to round to the nearest degree. And to do this, I'm going to do a method similar to what we saw when we were finding the unknown sides. So we're going to look at, okay, here's SOHCAHTOA, here's our different ratios that we can use. Let's look at the theta, that's what we're trying to find, and label everything with respect to that theta. So this is going to be our opposite, this is going to be our adjacent, and our hypotenuse will always be the side across from the right angle. So I know I'm not going to be using the opposite because there's nothing there and I'm not trying to find it. So I'm going to go ahead and cross off anything with an O, and that means I'm going to be using ka, which means cosine. So if you remember, I keep saying when you use a trig function, you have to be using it with an angle. So in this case, I don't know the angle, but the cosine is going to get attached with that angle because it's really going to be cosine of that angle is equal to the adjacent side, so 14, to the hypotenuse. So now hopefully you're thinking, well, this looks a lot like what you just saw up top, because it is. It's exactly the same thing. So I want to solve this for the angle. So instead of putting this over 1 and cross multiplying, I wouldn't want to do that because I'm trying to get theta by itself. So to get theta by itself, I just need to undo cosine. And in order to undo cosine, we're going to take cos inverse of both sides. We're going to take the inverse. So that means theta is equal to cos inverse of 14 over 32. And you're going to type that in your calculator just like what you did before. So you're going to go to the trig button, go down to cos inverse, 14 divided by 32, and we get 64.0555. We're rounding that to the nearest degree, so it's going to be approximately 64 degrees. So there's our answer for that. And I'm going to go ahead and just make that approximately because it was a decimal in the calculator. Just like all these up top, I could really say these are all approximately because I didn't realize I didn't put the angle A here. Because they didn't come out to be whole numbers versus the 60 came out to a whole number. So the directions say to round, so you could just leave it as rounded. And then the last one here, we're going to do the same idea. So again, across from that right angle is the hypotenuse. Here's my acute angle I'm trying to find. Go opposite that is the opposite. Next to it is the adjacent. Thinking about SOHCAHTOA for this. Not using the hypotenuse, nothing there, so crossing off anything with an H means I'm going to be using tan. So it's tan of the angle, so tan of theta is equal to the opposite over the adjacent. So again, I don't want to put tan of theta over 1 and cross multiply because I'm trying to solve for the angle, which means I need to get rid of tan. So I need to undo that. So I'm going to take tan inverse of both sides. So those cancel, and I'm left with theta equals tan inverse of 26 over 18. And then we type that into our calculator. So I go to the trig button, tan inverse 26 over 18, and we end up with 55.3048. Again, we're going to round that to the nearest degree, so I'm going to say it's approximately 55 degrees. And that's it. So when you are solving for a side length, you are going to set up a proportion, cross multiply, and use sine, cosine, or tangent. When you're solving for an angle, you're going to still set up your your equation with your ratio, but the difference is you're going to be using the inverse trig functions to be able to undo the trig to be able to solve for the angle. So that's kind of the difference in the solving process. So go ahead, get your key ideas down and try the check your understanding problems, and we will talk about those in class tomorrow.